Hello friends and welcome back. I hope by now you have a good understanding of single dimensional arrays, searching and sorting. We will look at double dimensional arrays now. Double dimensional arrays builds upon the concepts of single dimensional arrays. So if you know single dimensional arrays really well, then understanding double dimensional arrays will be very easy for you. If you don't know about single dimensional arrays, then please go through its lessons first and then come back to this lesson. The need of double-dimensional arrays arises from our natural instinct to arrange data in a tabular format. Most of the times when we are dealing with data, we organize it as a table. Let's look at a few examples to make this point clear. How does your class teacher records the marks of the entire class in all subjects? He or she will create a table for it like this. How is the attendance of the class recorded in the attendance register? Again, using a table like this. If I ask you to write 3 differences between bubble sort and selection sort, most probably you will list them in a tabular form like this. I hope these examples give you a good idea about how we organize data in tables to manage it easily. Double-dimensional arrays help us organize data as tables in our Java programs. When I was explaining single-dimensional arrays, I said that you can visualize a single-dimensional array as a row of numbered boxes. Similarly, you can visualize a double-dimensional array as a group of single-dimensional arrays stacked upon each other like this. In a double-dimensional array, we need two subscripts to refer to an element within the array. First one is for the number of rows, and second one is for the number of columns. For example, if this 2D array contains these elements, then I can access this element using two subscripts like this, where ARR is the name of the array variable. This first subscript is the row, and this second subscript is the column. We specify the dimensions of a 2D array as number of rows by number of columns. This array has 4 rows and 5 columns. So we can write its dimensions like this. We will say that dimensions of this 2D array are 4 by 5. Like one-dimensional arrays, all elements of a double-dimensional array must be of the same type. Elements of different data types within a 2D array will lead to compilation errors. Next, let's see how we can declare and initialize a double-dimensional array. This statement declares ARR as a double-dimensional array. You can visualize ARR like this. ARR contains 3 rows and 2 columns. So dimensions of ARR are 3 by 2. Notice that there is an extra pair of square brackets in this statement. This specifies that the variable ARR represents a double-dimensional array. To understand this part, remember that a double-dimensional array is essentially a set of single-dimensional arrays, where each single-dimensional array forms one row of the double-dimensional array. Here, this first row can be considered one single-dimensional array. The second row can be considered another single-dimensional array. And this third row can be considered yet another single-dimensional array. To initialize the double-dimensional array, the rows are written as single-dimensional arrays like this. They are separated by commas and enclosed within a pair of curly brackets. Like single-dimensional arrays, here too we can place these two pair of square brackets between the data type and array name. Both these statements are equivalent. You can use whichever way you like. Let's see a few examples of declaring and initializing double-dimensional arrays of different data types. This first array A1 is the same array that we saw just now. Its dimensions are 3 by 2. You can get the total number of elements an array can hold by multiplying its number of rows with the number of columns. So A1 can hold 3 into 2, which is equal to 6 elements. The next array A2 is a 2D array of char type. It has 2 rows and 5 columns, so its dimensions are 2 by 5. It can hold 2 into 5, which is equal to 10 characters. After that, we have a 2D array A3 of double type. It has 3 rows and 3 columns. This makes its dimensions as 3 by 3 and it can hold 9 double values in it. Lastly, we have a 2D array A4 of string type. It has 2 rows and 3 columns, so its dimensions are 2 by 3 and it can hold 6 strings. An important concept in double-dimensional arrays is to display its elements in a matrix form. Displaying elements in matrix form means displaying the elements of the 2D array organized in rows and columns. For example, elements of this 2D array in matrix form will be displayed like this. Let's also see the matrix form of other examples that we saw earlier. As you can see here, the elements of all these 2D arrays are arranged in rows and columns to get their corresponding matrix form. Let's switch to BlueJ now to understand how to display a double-dimensional array in matrix form. I have this class with the main method already created. Now we will add code to initialize our int2d array ARR and print it in matrix form. First, mention the data type of your array. As I want an integer array, so I am writing int. Next, mention the name of your array variable. Let's name it ARR. After that, 2 pairs of square brackets to tell the compiler that we intend to create a double-dimensional array. Then, after the equal to sign, we will initialize our array. Start the initialization by specifying the curly braces. Inside the curly braces, first mention the double-dimensional array which will form the first row of ARR, then comma, then the second 1D array, again a comma, and then the third 1D array. Let's compile the program to ensure we have made no errors. Program compiled successfully. With that, our 2D array is declared as a 3 by 2 dimensional array and initialized with these values. At this point, I want to talk about the length attribute of a double-dimensional array. Recall that for a single-dimensional array, this used to give the size of the array. Let's print arr.length for a double-dimensional array and see what we get. It gives us 3. To understand why arr.length is 3, we need to again go back to the fact that a double-dimensional array is made up of many single-dimensional arrays. Each single-dimensional array forms one row of the double-dimensional array. Length attribute of a double-dimensional array is equal to the number of rows of the array, which is essentially the number of single-dimensional arrays that make up the double-dimensional array. So in this case, arr.length is 3 as arr has 3 rows. Now I will print arr of 0.length. What do you think will be the output of this statement? Let's execute the program and see. It gives 2. The reason is that arr of 0 refers to this 1D array. Length of this 1D array is 2, so arr of 0.length gives us 2. I hope this gives you some idea about how the length attribute works in case of a double-dimensional array. Just keep in mind that arr.length will give the number of rows of the 2D array and arr of 0, or for that matter arr of 1 or arr of 2 will give the number of columns. I will comment out these two statements. Now let's print this 2D array in matrix form. In matrix form, elements of ARR will be printed like this. Doing this is very simple. We will use nested for loops for it. The outer for loop is for number of rows. I will write it like this. For int I equal to 0. Remember that in Java, we start counting from 0, not 1. So the first row of the array is 0. Then the loop condition will be I less than 3. Rows of this array are numbered as 0, 1, 2, hence this condition I less than 3. And finally, I plus plus. Inside the outer loop, we will write the inner loop. It is for the number of columns. For int j equal to 0, j is 0 because, as I said before, in Java, we start counting from 0. The two columns of ARR are numbered 0 and 1, so the condition of inner loop will be j less than 2, and then j plus plus. Inside the inner loop, I will print the elements of the array like this. System.out.print ARR of. Now we need to mention the subscripts. The first square bracket is for the number of rows, so I will write I. The second square bracket is for the number of columns, so I will write j inside the second square brackets. As a space separates elements of a row, I will add a space here like this. Note that I have used system.out.print instead of system.out.println, as we need to print all elements of a row on the same line. Once this inner loop completes executing, one row of the array is printed. We want to start the next row from a new line. So after the inner loop, I will write a println statement like this. These parentheses of println are empty as we just want to print a new line and nothing else. With this, our program is ready. Let's execute it. The double-dimensional array ARR is printed correctly in matrix form. Next, I will do a dry run of this program to give you an in-depth understanding of its working. As we have already seen, this statement initializes ARR as a 2D array with dimensions as 3 by 2, that is 3 rows and 2 columns. This next statement prints 2D array printed in matrix form to the console. After this, the outer for loop starts and initializes I to 0. As the condition of outer loop is true, program control enters it and comes here. Inner for loop starts and j is initialized to 0. Condition of inner loop is true, so program control enters inside it. I is 0 and j is 0, so ARR of ij is ARR of 0, 0 for this iteration of the inner loop. ARR of 0, 0 means first element of first column. It is this element with the value 1. So 1 is printed to the console along with a space. I am repeating it again so that you remember this. I have used print here, not println, so whatever we print next will get printed on the same line. After this, j is incremented to 1. Condition of inner loop is true and program control comes here. ARR of 0, 1, which is this element 3, gets printed on the same line. Next, j becomes 2. Condition of inner loop is false, so loop is not executed and program control comes here. This statement prints a new line, so now whatever we will print will get printed on the next line. Program control goes back to the beginning of outer for. I is incremented to 1. Condition of outer for is true, so program control comes here. J is again initialized to 0. Condition of inner loop is true. Program control comes here. This time, ARR of 1, 0, which is this element, gets printed. In the next iteration of inner for loop, j becomes 1. ARR of 1, 1, which is this element, gets printed. After that, condition of inner loop becomes false. program control comes here and prints a new line so the next row can start on the next line. Then again, program control goes back to the beginning of outer for, and in a similar way, this third row is printed. I hope this gives you a good understanding of declaring and initializing a double-dimensional array and printing its elements in matrix form. Let's move to the next lesson now.